12x plus 9y equals 99. Beautiful. And the bottom one? 92. Now, Ashton, did you add or subtract these two equations? Very good. Why'd you subtract? Very good. They're both positive. If we had added these, would we eliminate anything? No. Okay. You have to subtract in this instance. Okay, so we're going to subtract the whole thing. What are you going to get for the x terms, Ashton? 0. Okay. Why? Okay. What's next? Plus y. Mm-hmm. Beautiful. So, what's y? Awesome. Y is 7. Now, it only asks for the y coordinate of the solution of the given system. So once we found y equals 7, we're done. Okay? If you were to have eliminated y, whatever you got for x, you would have wanted to plug that back into either equation. Okay? You could have done this problem through substitution. It would have been a little bit more difficult. Okay? I think elimination is the best method, and to eliminate those x's is perfect. So great job, Ashton. Okay, what about 46? What is the y-intercept of 2x plus 5y equals 15? Roy, what'd you get? 3. Very good. How'd you get 3? Walk me through it.
So, since you don't know what the y-intercept is, you have to solve for it.
Uh-huh.
Subtract it to x-intercept.
Very good. Because right now, we don't have it in what form? Y equals mx plus b. And what form do we call that? Slope-intercept. So we have to change this into slope-intercept form. Roy's on the the right track. So what he did first was you subtracted 2x from both sides. Beautiful. What's next, Roy? Okay. 5y equals 15 minus 2x. Beautiful. Divide by 5. Divide by 5. What'd you get? Beautiful. Remember that 5 gets distributed to both terms. So we get y equals 3 minus 2 over 5x. Now this isn't how we typically see y equals mx plus b form. Can we rearrange this, Roy, to look like y equals mx plus b? How do we rearrange it? Good. So how is it going to look? Good. Beautiful. So now our y-intercept is this number, which is our b. Very good. Oh, shoot. Guys, don't worry about 47. My bad. You only do 45 and 46. If you tried 47, good job. If you got it right, awesome. I don't know. I don't have it written down. I will find the answer and give it to you guys, though, for 47. I don't have it right now, though. Okay? All right. Good job on the warm-up. Like, oh, it looks like an elimination problem, okay? We're going to see more examples of this and figure out what we're supposed to do for each system that we get. Because some systems will be easier to use certain methods. Let's move on. Again, this is 6.4. It's going to be a quick little lesson, and then we'll be good to go. Ashton was. Our objective in this lesson is to choose the best method for solving a system of linear equations. Okay, so guys, we've already talked about 3 different ways, right? 6.1 was the graphing way, 6.2 was substitution, and 6.3 was elimination. Now, our objective in this lesson is to choose the best method for solving certain ones. So remember how in the war... All right, so I'll go back at the end, okay? For graphing, you want a visual display of the equations or when you want to estimate a solution, okay? So when you get really, really strange fractions and numbers, sometimes graphing is the best way to visualize the solution, okay? Where the 2 graphs cross. Substitution is when one equation is already solved for one variable or when it's easy to solve for one of the variables. And then elimination is when the coefficients of one variable are the same or opposites, or when it is not convenient to use graphing or substitution. You guys got this copied down? Let me know when, Ashton. Okay. There's also something, this is a little vocab, it's called a break-even point, okay? The break-even point for a business is the point at which income equals expenses. The graph shows the break-even point for one business. It's also known as the solution, where the 2 graphs are going to cross. Notice that the values of y on the red line represent dollars spent on expenses, and the values of y in the blue line represent dollars received as income. So y is used to represent both expenses and income. We're going to do a problem like this, but with our own money, okay? We're going to do a problem just like this, but with our own money, okay? So take a look at the next slide. We're going to make our own problem and find the solution. When would you use this in real life, okay? So let's think about our own money. Does anyone in here earn your money via allowance, via working? Anderson, what do you do?
I work like part-time, like little like freelance stuff.
Where?
Around my neighborhood or with my dad at his work.
Nice. What does he do?
He runs the Navy Police Athletic Team.
Awesome. So how much do you get paid?
For my dad, it's about $20 per
Oh.
thing.
Okay. So Anderson said he gets paid $20. So we're going to say Y. This is our earnings. So Y equals 20. X. And how much money would you say you started off this month with?
$5.
$5. Plus 5. So 5 is his starting amount. And he earns 20, let's say, per week. Per day, as an average. Sure. Or what would you say, per week?
Yeah.
How much do you make per week? $20?
Probably 20.
Okay.
30.
Sounds good. Expenses. Tessa, I need you to help me out here. What do you spend your money on? In a typical week? Food, clothes?
Yeah,
Food. How much do you spend on food, would you say?
I'd say like, I don't know, $20 something.
20 something? Let's make it 25. So let's make our food expense negative 25. The reason we make it negative is because our graph should be going down, right? Because we're not increasing our money, we're decreasing per week. And how much money do you think that you started off the week with, Tessa?
Okay, I started off like with at least $40.
At least 40, okay. So Tessa started off the week with 40, but she's expending her money by going down by $25 per week. Anderson started off with 5, and he's earning money with $20 per week. Where these graphs are going to meet is when Tessa and Anderson have the same amount of money, okay? Where these graphs meet is where Tessa and Anderson are going to have the same amount of money, okay? So let's go ahead and draw as best as we can a graph for this. Here's our y-axis, here's our x-axis. We're only focused on this first quadrant. And let's take a look. Let's make the earnings one our red one. And let's make the expenses one our blue one. Tessa's. Because she likes to spend a lot of money. Okay? Actually, flip that. I'm sorry. Earnings should be blue, because that's like blue, your earning stuff. And then the red one should be expenses. Because that's like you're going in the red. You're expending your money. Okay. So, let's do the red graph first. What do we know about the red graph? Expenses. Roy. Slope is negative 35. Sorry, 25. Yep. Y-intercept is 40. What do we know about the blue graph, our earnings? Tessa?
Your slope is 20.
Mm-hmm.
And your y-intercept is 5.
Y-intercept is 5. Okay, let's graph the red graph first. Let's do the red graph first. Where's the red graph? What's the first point I should put on the red graph? 0, 40. Very good. Where it crosses the y-intercept. So let's count by tens. 10, 20, 30, 40. Let's label this 40, and let's put a nice red dot right there at 40. Now our slope is negative 25, so how are we going to move? Down 25, and then where? So here's 10, here's 20, 25. So down 25, and then where? Across 1. So let's make this 1. This was 10, 20, 30, and let's move over 1. So here's our next point. This was down 25. Oops. And then plus 1. Let's do one more point. So if we go down 25, here's 5, here's 10. It should be at negative 10, and then over 1 more. So at 2. 2 weeks. So we've got 3 points. All we're going to do is draw a line connecting all 3 of them. What do we notice about Tessa's expenses? Going down pretty fast, right? Those $40 are over, and she's in the negatives after 2 weeks, okay? So it's not smart to spend $25 without making any money. Do you see how the negative 25 is really hurting her? Okay, let's see what happens with Anderson. So Anderson's graph, the blue one. How am I going to graph it? Someone help me out. Alan. Good, graph it at 5. So my y-intercept is 5. So that's going to be right here between 0 and 10. What do I do after that, Alan?
You go up 20.
Good, up 20. So up 20 should be where? Between 20 and 30, so right around here, that's 25. And then where do I move after that? To the right 1. So here's our next point. Let's plot one more. So we're going to go up 20, so right around 45. And then we're going to move to the right 1 again. This blue graph is going up. Does that make sense? Why does it make sense that the blue graph is going up and the red one's going down? Good, just because one's in earnings and one's expenses. Also, our slopes are positive and negative, right? So we should have 2 graphs that are going in opposite directions. Awesome. Okay, all we're going to do is draw a line connecting all 3 of those points. Now, for graphing purposes, go ahead and put a nice black dot where they meet. About roughly how many weeks would you say it took for them to have the same amount of money? Giancarlo? Almost 1, right? It's right around that 1. A little bit less than 1, right? So give me an approximation, like a decimal. 0.8? Okay. 0.8 weeks. Okay? This is very helpful when you guys are graphing to approximate. Okay? This is a good example of an approximate value. Okay? 0.8 weeks. To where Tessa and Anderson would have the same amount of money. And how much money, roughly, are they at? $20. Okay? Now, let's take one last look at the system that we just created. Why was this one so easy to use graphing? Why was it easy to use graphing for this system? Roy? Very good. Both of those equations are already in y equals mx plus b form, okay? That is the main takeaway from today's lesson, is that if we have equations in y equals mx plus b form, it is way easier just to graph them than to do any other method, okay? All right, next slide. We're not solving these, okay? I just want you guys to take a look and tell me whether we should substitute, eliminate, or graph each of these. What do we think we should do for 19 and why? Ashton? Substitution? What else? Substitution is a good one because we've got y in terms of x. What else is a really good one for number 1? Anderson? Graphing. Okay? Graphing. Why is it easy to graph these two? Anderson? They're simple equations, and then they're in what form? Very good. They're already in slope-intercept form. They're already in slope-intercept form, okay? So we already know that our slope of the first one is 3. Our y-intercept is -1. Our slope of the second one is 4. What's our y-intercept of the second one?
0.
If it's not there, it's 0. Very good, okay? Number 20. What do we think is the best method to use for number 20? Tessa?
Elimination.
Very good. Elimination. Why?
Because the threes are the same.
Good. The 3 m's are the same. So what's going to happen with those 3 m's?
You're gonna like subtract.
Very good. If we just subtract one from the other, they're going to eliminate. Beautiful. And 21. Anderson, what do you think? Substitution. Very good. Why?
Choose one equation where we just have a variable on one side.
Mm-hmm. What is that?
Y equals
Yeah, but the variable is t, right?
wait.
The fact that t was alone on the left side or on the right side, it's just like, okay, we're going to take that t, whatever t is equal to, we're going to plug that into the first equation, okay? That is the beauty of substitution, okay? Now, the first one was the only one that could have been or. But guys, realistically, you can use any method to solve any one of these, right? You can use elimination to solve the first one. You could use substitution to solve the second one. And you could use graphing to solve the third one. But it's not super easy if you pick the wrong method, okay? Some equations will be easier and some equations will be harder, okay? So on your test, there are going to be questions where it's going to ask you, you must use this method. Other equations where are going to say, do your best and use whichever method you would like, okay? And it's up to you guys to figure out, okay, this looks like an elimination problem. Let me use elimination. It looks like substitution. Let me use that one. or it looks like a graphing problem. Let me graph them. Questions so far? That's it, peeps.